Today we talk about polynomial functions, and a general polynomial function is a group of monomials linked by addition and subtraction. We know monomials have coefficients with variables and exponents. One of the things that's got to be true about a polynomial is that the coefficients out in front have to be real numbers, no I terms, and the exponents, or the end values in this case, have to be non-negative. So they can be 0, much like this. This is like x to the 0, this constant term here. The degree of the polynomial is the largest power of x, and then the coefficient of the term of the largest power is the leading coefficient. So let's say this were the largest exponent, a sub n would be the leading coefficient. So in this case, we look and ask, are these terms polynomials? You'll notice in each case there are no i's, so that checks off that list. All the exponents are even numbers. The leading coefficient in this case is actually going to be the coefficient in front of the x cubed. Alright, so 2/3 is my leading coefficient, and this is a third degree polynomial. In this case here, we look and this term causes a little bit of problems because we have an x in the denominator, and we know when that's the case we have x to the negative first. So because this exponent is negative, this is not a polynomial. Lastly, this certainly isn't in that form. We have an x in the denominator, and this is a rational expression, so this is not as well. Now, polynomial graphs are said to be continuous, smooth, and kind of curved. So this is an example of a possible polynomial graph. A quadratic is also a polynomial graph, but this is a higher degree polynomial. This, on the other hand, is not a polynomial. While it's continuous, you'll notice that it's not smooth and it's not curved. Right here you've got what we call a cusp or jagged edges, and here, so that's not a polynomial. Now, when we talk about polynomials, we talk about their coefficients and their exponents, and we call even polynomials polynomials that have a degree that is an even number, while an odd polynomial is a polynomial that has a degree of an odd number. And you'll notice that with even polynomials, they end up, no matter what they look like, this could be 2, 4, 6, 8, 10 for the n value, they will always, as long as that leading coefficient is positive, they will always go up on both sides, while an odd polynomial, 1, 3, 5, 7, 9, will always go up to the right and down to the left. So we've talked a little bit about end behavior freshman year, and what end behavior basically does is it talks about the y values when x is very large, both positively and negatively. So if we have an even degree, or a case like this, and we have a positive leading coefficient, so a sub n is positive, then when x gets very large in the positive direction, y will get very large, and when x is very large in the negative direction, y will get very large. And this is how we write end behavior. As x goes to infinity, f of x, which we know is y, goes to positive infinity, and when x goes to negative infinity, f of x, which is y, goes to negative infinity. Likewise, if the coefficient is negative and we still have an even degree, we know that whatever number we put here, very big, is going to be raised to an even power. This is going to be positive, but when we multiply it by a negative coefficient, it goes negative. And that happens both when we plug in a very big positive number or a very big negative number. For instance, if I had negative 100 x to the 28th. Put a very small negative in here, like negative billion, raise that to the 28th power, that's a positive number, and then multiply that by a negative 100, and it's very negative. So the end behavior here is that as x goes to infinity, f of x goes to negative infinity, and as x goes to negative infinity, f of x goes to negative infinity. So now let's look at an odd degree polynomial where we've got a positive coefficient, so something like, oh, I don't know, 100 x to the fifth. When I plug a very big positive number in, this is positive times a positive, still a positive. Very big negative number, that's a negative times a positive, which is a negative. So the end behavior is x goes to infinity, f of x goes to infinity, that's this part here. As x goes to negative infinity, f of x goes to negative infinity, that's this part here. Notice we're leaving these middles open because end behavior only describes what happens way out at positive infinity and negative infinity. Likewise, if I were to put negative 8x to the 7th, when I get a very big positive, raise it to the 7th, that's a very big positive number, multiplied by a negative, that's a negative, so that's this guy here. And take a very big negative number, raise it to the 7th, that goes positive, or I'm sorry, very big negative number, raise it to the 7th, that stays negative, but then multiply it by a negative, and that goes positive. So my end behavior is as x goes to infinity, f of x goes to negative infinity, this part here, and x goes to negative infinity, f of x goes to infinity, this part here. Here's just another little breakdown with some pictures for you. Leading coefficient, alright, is positive, and we have an even term, so this could be a x to the even, and this guy's positive, so we go up in both directions to the left and right. This is negative a x to the even, and you'll notice they both go down. Different stuff happens in between, but they're both going down at the end. Likewise, this is a positive a x to the odd, and to the right it's positive, to the left it's negative, right positive, left negative, and this is a negative a x to the odd. And you'll notice here when we go far right we're negative, when we go far left we're positive. So I want to know which of the following could be the graph of negative 3x to the fourth. So you'll notice we have an even term here, and we have a negative leading coefficient. So when I go x goes to positive infinity, I put a positive very large number in here, I get a positive out, multiply it by a negative, so I say x goes to infinity, f of x goes to a negative infinity. That's my end behavior, and I want to look at which one of these does that. Going to positive infinity, it goes down. So this one's out, this one's still okay, this one's okay, and this one's out. So now I want to look at what happens when I go negative. If x goes to negative infinity, what's f of x do? Put a negative number in here, raise it to the fourth power. That's going to go positive, but I multiply it by a negative, and that goes negative. So I want something going down in both directions, which means this is out, and b is my term. So the maximum number of times a polynomial can intersect the x-axis is the same as the degree of the polynomial. So for instance, and that's the maximum number. It doesn't necessarily have to cross any times, but the most it can cross is the degree of the numbers. So a polynomial with even degrees can have any number from 0 to n real roots. So you'll see here, this is a fourth degree polynomial with no zeros. It doesn't cross at all. This has a fourth degree polynomial, 2, 3, 4 roots. Alright, 1, 2, 3, 4. And this is a fourth or sixth degree polynomial, they're saying, with only 2 roots. If I have an odd polynomial, then it could cross anywhere from 1 to n times, and that kind of makes a lot of sense because we know odds go up in one direction and down in another direction forever and ever. So if that's the case, at some point they have to cross that horizontal axis. All right, that's why we could have 1 here and 0 here, since these both go either up or down depending on their maximum and minimum values. They may never cross that horizontal if they stay in this area here. So in this case, we have a third degree polynomial, 1 root. Third degree polynomial, 3 roots, crosses 3 times. Fifth degree polynomial with 1, 2, 3, 4, 5 roots. Want to describe the end behavior of each of these, so we're going to say as x goes to infinity, what does f of x do? And as x goes to infinity, what does f of x do? Likewise here, x goes to infinity, x goes to negative infinity, what does f of x do? And basically all we need to do is take a look at that leading coefficient. So in this case, I have an odd term with an positive leading coefficient. So if I go very big positive, take it to the 5th power, it's still positive. Multiply by a positive, that's positive. So we go to a positive infinity. Means we're going like this. When I plug a very big negative and take it to the 5th power, that's still negative, and then I multiply that by a positive 6, and it's still negative. So this looks something like this. Therefore, f of x goes to negative infinity. Now in this term, we'll notice we have an even degree and a negative leading coefficient. So as I plug in a big positive number and raise it to the 22nd, it still remains positive, but I multiply by a negative, and that goes negative. So this is going down in this direction. Thus, f of x goes to negative infinity. Likewise, when I plug in a negative infinity, raise it to the 22nd power, it goes positive, but I multiply that by a negative number, and that stays negative. So therefore, we get negative infinity here. So we want to state the end behavior of these graphs right here. If the function has an even or an odd degree, if the function has a positive or negative leading coefficient, and how many roots the function has. So, state the end behavior. You'll notice as we go far right, as x goes to infinity, f of x goes down, so that's going to negative infinity. And then as x goes to negative infinity, f of x is going up. So that goes to a positive infinity. We want to know if this function is even or odd. Well, if it's even, they either both go up or both go down. So this has to be odd. If the function has a positive or negative leading coefficient, well, if this were an odd function, let's say it's to the 5th, then as I plug in a positive number, if the leading coefficient were positive, then I'd have a positive times a positive, it would go up. So as I plug in a positive number, since this goes down, we have to have a negative leading coefficient. All right, and then how many real roots are there in this function? How many times does it cross the axis? It appears twice. 2 roots. You'll notice in this graph, both sides are going down, so as x goes to infinity, f of x goes to negative infinity, and as x goes to negative infinity, f of x goes to negative infinity. We want to know whether it's even or odd. Since it does the same thing on both sides, that must be an even function. then we want to know if it has a positive or negative leading coefficient. Well, let's just throw x to the 8th as an even function. If I plug a very big positive and a very big negative into this, they come out positive, which means it would go up. So in order for those to go down, I'd have to have a negative leading coefficient. So this has got a negative lead as well. And how many times does it cross? 1, 2, 3 times. Alright, so a little function notation with polynomials. We've done this freshman year. We've already done it this year a little bit. If my function is f of x is equal to 3x squared minus 2x plus 4, what's f of negative 2? This is a straight substitution, taking this 2, substituting it for x. So I have 3 times negative 2 squared minus 2 times negative 2 plus 4. And I just evaluate that. That's 4, 12, 18, 4, 12, 16, and 20. Now, this is a case where I have to plug in w plus 1 for every x. So when I do that, I get the following. I get 3 times w plus 1 squared minus 2 times w plus 1 plus 4. In order to clean this up, I'm going to need to FOIL this term out, and we know that that is w plus 1 times w plus 1, so this is 3 times w squared plus 2w plus 1 minus 2w minus 2 plus 4. Multiply through, I get 3w squared plus 6w plus 3 minus 2w plus minus 2 plus 4. Combine like terms, 3w squared, there's a 6 minus 2, which is 4w. Then I have 7 minus 2 is 5. And that's my simplified solution. Likewise, this says instead of x, plug in 3x plus 1, very similar to the last problem. So I have 3 times 3x plus 1 quantity squared minus 2 times 3x plus 1 plus 4. FOIL, I have 3 times 9x squared plus 6x plus 1 minus 6x minus 2 plus 4, which is 27x squared plus 18x plus 3 minus 6x minus 2 plus 4. Like terms, 27x squared, 18 minus 6 is 12x. 3 minus 2 is 1, plus 4 is 5. There's my solution. Here's your basic rundown on end behavior and polynomial functions. Do your connect add problems and write your lesson summary, and we'll see you tomorrow.